Hello everyone, this is Dr. Dhiman and I welcome you all to this microprocessor tutorial series. So in this video we will learn about the timing diagram for the input output write machine cycle. So this is the most important part here. So we'll consider one example, that is the out instruction. Suppose we have the out instruction out 0 1 8. This is the operation, and for this operation opcode will be equal to, this is D3H, and this is the address of the output device. So whatever be the content of the accumulator after executing this instruction, that will be transferred to that output device of which address is 01 in hex code. Okay, suppose we have the microprocessor here and we have a output device. Okay, so whatever be the content in the accumulator of this microprocessor, that will be written into the output device. So this is a 2-byte instruction. So for the first byte is the D3, that is the opcode. Okay, and the second one is the operand, or here this is the address of the output device or output LED display. Suppose the memory address, suppose we have two memory addresses, arbitrary memory addresses, 2050 and 2051. These are two consecutive memory address, and this memory address, the contents are the, suppose D3 here in hex code, and here we have 01H in hex code. So what will be the binary representation? It will be 1101 0011. Okay, so this is for D3, and for 01H it will be 00000001. Okay, so these are the respective binary code, and this binary code is the address of the output device, and this binary code is the opcode in machine code form. Okay, this is the operation code. So when the microprocessor will execute the given instruction, this one is the instruction. Okay, when the microprocessor will find this instruction to execute, first of all it will read the locations 2050 and 2051. These are the locations, and in that location it will be finding the opcode. Opcode is this one, and it will find the output device address, that is the 01. This is the address, this is not the data. Okay, so whatever be the content of the accumulator, that will be the data that is to be written into the output device. This 01 is the address of the output device. Okay, so you have to be clear about these 2 points. Now let us understand that the microprocessor wants to transfer the accumulator data into the output device. Here in this case, suppose we have a LED display, that is the output device, that will show the data, that is the content of the accumulator, or we can say that the output LED display, it will represent or it will show the accumulator content. Okay, now we have to transfer the content of the accumulator into this output device. So now let us see the timing diagram. So during the timing diagram, so before going to timing diagram, let us see the timing diagram table. We have already covered this opcode fetch operation, memory read, memory write, input output read in our last video, and in this video we will learn about the input output write. So as it is a write operation, so in the case of write operation, S1 and S0, these are the status signals. These status signals will be 0 and 1 respectively. This is not a read operation, therefore this is 1. Read is the RD bar is the active low signal. When it is 1, this will be disabled. Read operation will not be performed. This is the write operation, and it is also a active low signal. Therefore we have a 0 value here. Input output or memory bar, this one is related to whether we have to choose the input output device or we have to go to the memory. So when the input output / M bar is 1, it will select the microprocessor will select the input output operation. Okay, input output device related operation. When it is 0, then this is related to the memory operation. So here in this case, in the case of input output write, we have the input output related operation. Therefore this is 1, and this INTS signal, this is related to the interrupt acknowledgement. Therefore when we have the operation is interrupt acknowledgement, then only it will be 0, otherwise it is 1 for all the other cases. We have already covered these 4 cases, and in this video we will see the timing diagram for the input output write operation. That means we have to transfer the content of the accumulator in this instruction, that is the out instruction. So during this instruction, whatever be the content of the accumulator, this will be transferred to that output device of which address is 01, okay, in hex code. Now let us see the out instruction timing diagram. So this is the out instruction here, and we have 3 machine cycle. One is the opcode fetch, memory read, and input output write. So we have already learned about the opcode fetch, we have learned about the memory read. In this video we will be concerned with the input output write operation. So let me write down in the right hand side about this port. Now let us understand one by one. During the first clock cycle, what we have to do, we have to transfer the output device address into the interfacing unit or the output interfacing unit. Okay, so this address, that is the 01H in our given instruction. So let me write down the instruction here also. The out 01, out is the operation code and 01 is the address of the output device. So this address of the output device 01, this will be loaded into both the address bus as well as the multiplex address data bus. Okay, because this 01 is the 8-bit address and the 8085 microprocessor, the overall address bus is the 16-bit memory address. So as we have 8-bit memory address, we will load the address of the output device into both the address data multiplex bus as well as the address bus. Okay, so we have loaded during the first clock cycle this address data multiplex bus. The address data multiplex bus will be working as the address bus. So to make it, we have to make the ALE signal high during the first clock cycle. This input output / amber signal, as this is the input output write operation in this video we are learning about. So this is the input output related operation, therefore this signal will be high during the entire cycle. Okay, now let us go to this read bar signal. This is the write operation, therefore this read bar signal will be high. This is the active low signal. This read bar signal, this read operation will be performed only when this read bar signal is equal to 0. As it is a write operation, input output write operation, therefore this signal will be high during the entire period of this machine cycle. Okay, we have 3 T states. During all the 3 T states, we have to make this read bar signal equal to 0. And this memory read bar signal, so this is related to the memory. We have the input output related operation now. In this video we are learning about the input output write operation, therefore this memory read operation is not applicable here. Therefore we have to make the signal high as well here. Why high? Because this is the active low signal. Here you can see memory bar, this is the active low signal. When it is high, this will be disabled. Now in this case, during the second clock cycle, after getting the address of the output device, what we have to do, we have to write the content of the accumulator into the required output device, okay, or the targeted output device. Therefore as it is a write operation related to the input output device, it is a active low signal. Therefore during the second clock cycle we have to make the WR bar signal 0. During the first clock cycle it was the address transfer. During the second and the third clock cycle, whatever be the content of the accumulator, it will be transferred into the output device. And what about the input output bar signal? This is also active low signal, so we have to make this signal as well as is low during the data transfer. So during this period from here to here, what we have to do, we have to transfer the data. Now let us see. So accumulator content will be loaded into the address data multiplex bus, and during this period this ALE signal is low. Therefore this address data multiplex bus will be working as a data bus. Therefore whatever be the content of the accumulator, it will be here in this data bus, and this data bus will carry the content of the accumulator to the targeted output device. Okay, this much for today. Thank you for watching. If you have any question, please put it in the comment section below. Also like, share and subscribe to my channel. Thank you.